Welcome to today's video on Cambridge IGCSE Mathematics 0607 and 0580. The topic for today is functions, where we will be looking at the subtopic quadratic functions. Quadratic functions are generally given in the format of ax squared plus bx plus c, where a, b, and c would be different constants. Now, if the value of a is positive, then we would end up with a U-shaped curve. The graph of our quadratic function would be a U-shaped, something similar to the one that we can see over here. And we call these graphs minimum graphs because they have a minimum point as their vertex. On the other hand, if the value of a that we have, that's the coefficient of our x squared, if it's instead negative, then we would end up with an N-shaped graph, which is also known as a maximum curve. So the curve would look something like this, and this is known as a maximum curve. And we say it's a maximum curve because it has a vertex that's a maximum. We're going to go ahead and learn how we can work out the equation of different quadratic functions when we have been given different starting points. So in this example that we're going to be looking at, what if we have been given the vertex, which could be a maximum or minimum, and being given one other point or one other coordinate on our graph? How will we be able to find the equation of our quadratic function? Now, it's important to remember that when we have quadratic functions, we can have it in the form of y is equals to ax squared plus bx plus c. And this is a standard form that we have. But we can also have it written in the form of y is equals to a x minus h squared plus k. And this format is also known as complete to the square format or the vertex form. Now, in this vertex form, h gives us the x coordinate of our vertex. I'm going to say this is vx. And k gives us the y coordinate of our vertex. I'm going to say that's vy. Let's look at the example that I've given here. It says, if the vertex and coordinates of one point is given, for example, let the vertex be 2, 3, and the other point be 3, 8. The first thing that we're going to do is we're going to use the vertex form of the equation, and instead of h, we're going to substitute the value of our vertex, that's 2 here, and instead of k, we're going to substitute the y value of our vertex, that's 3 here. And this would build up the equation y is equals to a x minus 2 squared plus 3. Our next step would be substituting the coordinate that we have been given. Now, we know the coordinate that we have been given is 3, 8. So the 3 would be substituted for x and the 8 would be substituted for y. And this would build up the equation 8 is equals to a 3 minus 2 squared plus 3. So if we figure out what 3 minus 2 is, that's just 1. So 8 is equals to a plus 3. And if we find out what a is and solve for a, we would see a would be 8 minus 3. And that's going to give us the answer of a as 5. Now, once we have the value of a, we can plug all of the other values that we have already found out. So we know h is 2, k is 3, and a is 5. So we're going to substitute that into our equation, and we're going to end up with y is equals to 5, x minus 2 squared plus 3. What we can do at this point is we can expand this equation. So we can multiply 5 by x minus 2 squared. So to work out what x minus 2 squared is, we can do this separately. So x minus 2 times x minus 2. And we would get x squared minus 4x plus 4. And we can multiply all of that by 5 to get 5x squared minus 20x plus 20. And we have the plus 3 from before. Then we can collect the like terms that we have. In this case, that's 20 and 3 to give us our final equation as y is equals to 5x squared minus 20x plus 23. And we can see that we've gotten this equation in the form of y is equals to ax squared plus bx plus c, which is a standard form in which we give quadratic equations. The next example that we're going to discuss is in questions where we have been given the x-intercept and a point, how would we be able to build up the equation of our quadratic function? Now, we already know that the equation of our quadratic function would always be in the format of y is equals to ax squared plus bx plus c. And I can factorize this to give me the equation y is equals to n x plus k times x plus h. Now, if we look at the example that they've given us here, they've let us know that the x-intercepts are -1, 0 and 3, 0. And the coordinate of the other point is 2, -6. Now, remember that when we have been given the x-intercepts, we can also call our x-intercepts as the roots of our function. And what this basically tells us is that if I look at x plus k and x plus h, x plus k would give me the value of 0 at a root, as well as x plus h should give us the value of 0 at our second root if it's available. Now, if I look at the root that we've been given, the first root that we've been given is -1. So I'm going to replace x with -1 here. And this means that my value of k should be +1. Similarly, I can also work out what the value of h would be. So I know x plus h should be 0. The second root is 3, so x would be 3 at my second root, and h would be -3. So you can see that the value of k and h are just the negatives of the two different roots that we have. So we have k as +1 and h as -3, giving us the equation y is equals to n x plus 1 times x minus 3. Now, to work out what the value of n would be, we can just go ahead and substitute the second coordinate that we've been given. That's 2 and -6. So instead of x here, we're going to substitute 2. And instead of y here, we're going to substitute -6, which gives us the equation -6 is equals to n times 2 plus 1 times 2 minus 3. So 2 plus 1 is 3. 2 minus 3 is -1, and if you solve for n, we would get the value of n as 2. If you put all of that together, so that's the value of n, k, and h together into our equation, we have y is equals to 2 times x plus 1 times x minus 3. And what we can do to get the equation in our standard form, that's in the format of ax squared plus bx plus c, is we can just go ahead and expand this equation. So we can start expanding step by step. And the first thing that we would do would be doing 2 times x plus 1, which would give us 2x plus 2. And then we would multiply this by x minus 3. So remember that when we have to expand two brackets like this, so this is expanding of double brackets. So we have 2x plus 2 and x minus 3. You have to times every term from your first bracket by every single term inside your second bracket. And if we expand it correctly, we'd end up with the terms 2x squared minus 6x plus 2x minus 6. We're going to collect the like terms, so -6x and 2x, which would give us -4x, forming our final equation, y is equals to 2x squared minus 4x minus 6. We're also going to look at how we can build up the equation of a quadratic functions if we have been given the vertex or the x-intercept. And it has also been stated that the value of a is equals to 1. Now, a is the coefficient of our x squared. And if we have the standard form of our quadratic equation, then that is y is equals to ax squared plus bx plus c. And if a is 1, we can do this in a little bit different or in an easier way. So let's look at the example that they've given us here. They said, find the equation of the quadratic curve of the form y is equals to ax squared plus bx plus c. And here you can see that they have not given this as ax squared plus bx plus c. They've just given y is equals to x squared plus bx plus c, which indicates that the value of a should be equals to 1. And they've also mentioned that the roots of this equation is -2, 0 and 3, 0. So the first thing that we're going to do is we're going to look at this because we've been given the roots. I'm going to look at the equation in the format of y is equals to n x plus k times x plus h. Now, because a is a 1, I can say n should also be 1, and I can remove the n from here. So I have y is equals to x plus k times x plus h. Now, the value of k and h would just be the negative of our roots. So k would be positive 2, and h would be negative 3. So y is equals to x plus 2 times x minus 3. And once we've gotten this, we can quickly go ahead and just expand this. So we would multiply every term in our first bracket by every term in our second bracket. And when we do that, we would get y is equals to x squared minus 3x plus 2x minus 6, which gives us a final answer if we collect our like terms together as y is equals to x squared minus x minus 6. That's all we have on today's video. Thank you.
Subscribe us now for more videos and content.